Welcome once again. Today we'll continue with our number theory and computation worksheet, and we will venture straight into God's word as we are accustomed doing. In Genesis 18:14, and let's read together, it says, "Is anything too hard for the Lord? At the time appointed, I will return unto thee according to the time of life, and Sarah shall have a son." So, based on that word, my declaration, which should also be yours, is no problem that I'm dealing with is too hard for the Lord to solve. And this declaration is so timely, especially when we are solving lots of problems in maths. No problem is too hard for the Lord to solve. So let us keep that in mind as we continue to solve these problems before us. So question number 1. What is the value of the digit 7 in 70,893? When you are given questions like these, it helps if we can write each of those digits in the form of a table where we can show the place value of each of those digits. So we're going to do a quick recap here. Let's see if we can position those digits in our table. So let's start with the last digit, 39807. So this first one is our unit position, our ones. This is our tens. This is our hundreds. This is our thousands. Right, barely get it in there. And this is our 10 of thousands position. Of course, you could write all the words. So they want us to identify what is the place value of 7. So to identify the place value or to work it out, you take 7 and it occupies the 10,000 position. So you multiply it and the answer there is 70,000. And you'll know that you're correct when you sound out the actual number. That number is 70, listen to the 70,893. So the answer there is 7 has a place value of 70,000. Let's go to question number 2. In question number 2, you're given some fractions and you ask to simplify that. But the rule that we should bear in mind, some of us know it as BODMAS. And it simply tells you the order of what we call the order of operations, how we should perform our addition, multiplication, subtraction, division, and so on. But you also have a rule called BODMAS. Now, I don't want to confuse you. The BODMAS is fine, but this BODMAS simply tells us that we work parentheses or brackets, right? So it corresponds. If you have any exponents or powers, meaning that if you have something like 3/4 square, right, you'll work that first. After, of course, you would have performed the brackets operations if there are any. And then, of course, you go ahead with your multiplication, division, and so on. Now, always work from left to right, be it multiplication or division operations. But let's illustrate in this simple example how the order of operation or the order of operations work here. So we are seeing, if you are seeing what I am seeing a subtraction here, then we have a what? A division. So notice in both cases, the division comes before the subtraction. That's the last operation we do. So in solving this problem, we will not subtract first. What we'll do instead is that we'll divide these two, get an answer, and then we will subtract the result. from 4 and 1/3. So let's do that. Two and 5/6 divided by 2 and 2/3. Now, when I have my questions written like this, when I say this, what do I mean? I have what I call mixed numbers here. You may be wondering what are mixed numbers. A mixed number consists of a whole number, then you have your fraction. So it's a whole number plus a fraction. That's a mixed number. And you have two mixed numbers here, 2 and 5/6 and 2 and 2/3. Now, I always like to write my mixed numbers as improper fractions, and then I like to work with those. So let's do that. How do we write them as improper fractions? Easy. You take your mixed number, you multiply it by the denominator, and then you add your numerator. So 6 2s are 12, plus 5 will be 17. And then I keep my denominator, that's 17/6. So 2 and 5/6 is 17/6. And we are dividing that by 2 and 2/3, which is 2 multiplied by 3, 6 plus 2, 8/3. Now there's another rule. And before I go on to that rule, let's recap. Improper fractions, where you have your denominator is always greater than your, sorry, not your denominator, your numerator is always greater than your denominator. Your numerator is greater than your denominator. That makes it an improper fraction. And as we are revising, a proper fraction, on the other hand, is the opposite. Proper fraction is where you have your numerator being less than your denominator, or your denominator greater than your numerator. So these are two examples of proper fraction. Notice how your numerator is always less than your denominator. So let's continue with this problem. So what I was about to say is that when you are dividing two quantities in math, your next line should read where you show a multiplication sign, and the second fraction that follows, you invert it, so it becomes 8/3. There you go. So it's 17/6 multiplied by 3 2s are 6 and 2, 8. Right, let's fix that. Notice I did not invert it there. You invert it, so it should read what? Are you seeing that? 3/8. So denominator goes up, becomes the numerator. Numerator goes down, becomes the denominator. And what I've done there, I've just inverted. Now there's a word in maths that we use. They call 3/8. And this is the word you may see. They call it the reciprocal. The reciprocal of 8/3. Right, so let's cancel. 3 divided by 3 is 1, 3 and 6 is 2. So this answer works out to be 17/8 2s are 16. So we have an answer there. 17 divided by 16. So the sum becomes now, let's write it. The sum becomes now 4 and 1/3 minus 17/16. And we can rewrite this part here as an improper fraction. 4 3s are 12, 1 is 13/3 minus 17/16. So I'm going to erase this side, and let's get some space where we can continue working this sum. Now, As we continue solving this problem, you have to work out what is called your lowest common multiple. Some texts may have it as the lowest common denominator, right? But we know it as the lowest common multiple. And I will show you how to do that. So if you have, as we have here, two fractions and you're subtracting, you take the denominator and you could simply 3 into 3, 1, right? You bring down the 16, you divide down. Now, it doesn't make sense dividing all the way down by 2 because there are no other even numbers. So your LCM in this case will be 3 by 16, which will be 48. Let's rewrite that sum here. 13 over 3 minus 17 over 16, LCM 48. And let's pay attention with respect to what we do when we simplify this. First, you take your denominator and you divide it. Not your denominator, sorry, you take your LCM, which is 48, and you divide it by the denominator here. 40 divided by 3, we can work that on the calculator, and we're going to get 16. And then, let's do that, 48 divided by 3, 16, and then we multiply the answer by the numerator. So that'll be 16 by 13. 28, let's go over that again. Take the LCM divided by the denominator. We are working at on a calculator. 40 divided by 3 will give us 16, 16, and then you multiply that 16 by a numerator. 16 by 13 is 208. And we write our 208 right here. So this first part will be 208, and we do the same thing here. 48 divided by that 16 on the calculator, it will give us 3. And let's do it again. And then we take that 3 and multiply it by the numerator. This time it's 17, and your answer becomes, sorry, 51, right? So we saw it just now. Let's do it again. 17 by 3. 51. Okay, so what do we have? We have a very nice problem right here. 51. So when we subtract, let's do it. 28 minus, excuse, 51, 157 over 48. So this answer will be 157 over 48. Now, you know, we can stop that and say that's the end of the problem and you'll be correct once we didn't make any mistakes. So what I'll be advising you to do, we all make errors sometimes, including myself. Always check over your work to make sure that there aren't any errors. So I'm assuming that this was solved correctly. Now, this answer is written as an improper fraction right there. That's an improper fraction. And if you were asked, let me show you a little trick here. If you were asked to write this as a mixed number, let me show you what you can do. And we're going to use our calculator to help us. You take take that 157 divided by 48. So the calculator is doing all the work here for you. Right, watch what's happening there. You got 3 points and you have a fraction, decimal part of the answer. Now, it means that that 3 will be the whole number part of the mixed number. So let me write that quickly. So that 3 will be the whole number part. And then the fraction or the piece or the decimal portion that remains we're going to multiply that by the denominator, which is 48. So this is what you do. We need to get rid of that 3 minus the 3. So notice we are left with just the decimal part, right? Now to get the fraction, because we want to write it as a mixed number, you multiply this, which is the 0.2, just the decimal part alone, by your denominator here, which is the 48, whatever that denominator is, you multiply it by that, and it will be 13. And that is what we're going to write over our 48. So this is 3 and 13 over 48. So there's no need to do any long division. You can use your calculator. And I think that's worth a quick recap. If you are given any fraction as an improper fraction, let's say you had 217 and you divided that by 65, and you want to write that as a mixed number, let me go through the steps for you. You take the calculator and you divide 217 by 65, and you will get the whole number and some decimal part remaining. You take away the whole number and you are left with the decimal part, and it's the decimal part that you'll multiply by what? This 65, and you'll get a whole number, and then you just rewrite that whole number answer over the 65 to give us the fraction part. So let's try it again. On the calculator this time, writing this as a mixed number, 217 divided by 65. Notice what we got here, 3 again, like 3 seem to be very popular, 3 point. So you just want, okay, let me take my time. So that 3 will be here. That's the whole number part, 3 point something. And let me now work out what's the fraction part. So I will remove that 3 by simply subtracting the 3. It will be to be left with the fraction or the decimal portion. And then this piece is what I multiply by, you guess it right, 65. So whatever number is in that denominator, you multiply it. And you see how we get 22? And it is that 22 that you are putting as your numerator, and you are keeping your what? 65. And of course, it will be easy to check this on the calculator. You simply divide 22 by 65. Right? Or let's just see if this will give us the same answer here. You multiply, if you want to convert this back to a mixed number, 3 by 65 plus 22 should give us the 217. Let's do that quickly. So you see how much fun maths can be? So let's cancel it down. 3 multiplied by 65. That'll give us 195. Then we add the numerator, and we are left with 217, which is exactly what we have there, right? So remember, that's how you use your calculator. So that'll give you 217 again over what? 65. So now you know. Now you know. No need to go and do all those long division and take a lot of time. You can have your calculator as your helper right there. That's what it is made for, to help you, make it easier for you in your calculations. Okay, so well done. Let's go on to question number 3. So question number 3 is asking us, again, we're dealing with our fractions and decimals. This one is making use of what we should know about a circle. What fraction of the circle below is shaded? Okay, so let's shade it, and so we'll be able to answer this question properly. So let me see if I shade this portion right here. So this little piece, which resembles the slice of a pie or a cake, they call that the sector. But it's called the minor sector because it is smaller than. This one is also called a sector. The one that is unshaded is bigger than the little slice there. It's called a major sector, right? And you'll be meeting more about the circle when we look at some measurements questions. But for our purpose right now, we need to find out what fraction of the circle is shaded and what is unshaded. Now, to help us work that out, a couple of things to note. The total degrees at the center of the circle as shown here, right around, is 360 degrees. Now, out of that 360, it is only the 60 degrees, which is the angle between those two radii there. Oh, what's a radii? That's it right there. Singular is radius. And since you have two of them, look another one here. The plural will be radii, R-A-D-I-I, radii. So that's 60 degrees. To find the fraction that is shaded, since it is only this piece here representing 60 degrees, that part of the whole that is shaded, you will take your 60 degrees, put it over the 360, which is the whole. And then, of course, well, you don't need to preoccupy your mind too much with the degree sign up there, but it helps, right? And then you simplify, cancel out your zeros, 6 into 6, 1. 36 divided by 6 is 6. So it's 1/6 of the circle. That's the fraction that is what? Shaded. And let's look at the fraction that is unshaded. So if 60 degrees is accounted for up here for the minor sector, it means that the angle below here would be 300 because the total must be what? 360. So the part that is unshaded, the fraction that is unshaded would be the 300 degrees over the 360. Again, let's cancel out. 5 could go into 30, or 6 could go into 35. 6 could go into 30, it's 5, 6. Now, that is not by coincidence that 5/6 of the whole is unshaded and 1/6 is shaded. Huh? When you add both fractions, you're supposed to end up with the whole, which is 1. So let's just check that. 1/6 plus 5/6. Your LCM is 6. And you say 6 divided by 6 is 1. 1 by 1 is 1. 6 divided by 6 is 1 by 5 is 5. So that will give us 6 out of 6, which is your whole. Now, what is the importance of that? Let me tell you. If you already knew that 1/6 was shaded, to find out the unshaded portion, you simply take away 1/6 from the whole, which we know is 6 out of 6. And since your denominator is the same, you can write back the ones. You write it once, the 6, and you simply subtract 1 from 6. So this will give us what? 5 over 6. Let's make sure that magic did not slip you. Let's do it again. If you're given two fractions and the denominator is the same number, only when they are the same number, if they are different, you cannot use this approach, and you ask to add it. You write the denominator once, and you simply sum the numerator. 5 plus 2 would be 7. 7/8. Okay, so 5/6 using this method here would be unshaded.